Okay, so what we're going to do is we are going to test the rules we developed for parallel circuits with a real parallel circuit. So if you need to go back and watch the roller coaster video that developed our rules for parallel circuits, voltage, current, and resistors, please do so before watching this video. Go back, watch it, because we're going to test those rules. So what I have here is a basic parallel circuit. I've got it hooked up to a power supply over here instead of battery, so it'll be a little bit more stable. But we want to test four things. We want to test our rule for voltages. So the voltage provided by our power supply, or the battery, should be equal to the voltage across the red resistor and the voltage across the green resistor. We then want to test our rule for currents. We want to know if the current going through each resistor, through each branch, do they add up to the current being provided by the battery before the split happens? So does the current here add up to the current through those two branches? Then we want to see if we can use Ohm's law to figure out the value of that red resistor and the value of the green resistor. And finally, we want to check the rule about the total resistance. Remember, in series, the total resistance of the circuit, we just add them together, and that's it. But for parallel, we have that weird thing happening because there's multiple paths, which lowers the total resistance of the circuit. So we want to check out that rule that we have with the fraction. And if I do the 1 over and the 1 over, does that give us the total resistance that we would expect from Ohm's law? Okay? So, like I said, go back and watch the rules for roller coaster parallel circuits. But here we go. And you can pause, rewind anytime. So, first things first. We're going to measure our voltages across each resistor as well as coming from the power supply. So I'm going to turn this on. Hopefully it's not too loud. And we'll get our meter and we'll set that to voltage. And let's get measuring. So first thing I'm going to do is measure the voltage coming in from the power supply. So I'm going to do that at the extreme ends here. So we measure that. And across the extreme edges, I've got 2.44, looks like. Oh, we'll round that, 2.45. So 2.45 for the voltage across our battery. So we'll get that in there. So that's the voltage here. Let's see what the voltage is at each of these spots. So we'll do the red. I go across the red resistor, and I've got 2.42 volts. That's pretty close, 2.42 volts. And across the green, let's see what we got. 2.40. Okay, so make sure you enter these answers, these numbers, in this Google survey that's below this video. Feel free to pause it, open it up as a second window, but in that Google sheet is where, that survey sheet, that's where you're putting your data for this, okay? So make sure you've got that open as a separate tab. You can pause, enter your numbers, but that's where they go. All right, so looking at these voltages, they're not exactly equal, but they're pretty close. They're pretty close. So does that our rule hold? Not bad, not bad. All right, so let's check out the current. So our rule for the current. So we need to get the current in 3 different spots. The current coming out of the battery, from the battery. So to do that, what I'm going to do is first I have to change the meter, put it over to amps, take that plug out, put it on amps, and let's measure the current that's coming out of the battery right to the junction point. So we'll open that up. So now we can measure the current going through here to get to the junction. And we've got, let it settle out for a moment, 0.5, we'll round that, 0.57 amps. So, let's see here. We'll write that down. 0.57 amps is our total there. Again, these numbers go in the spreadsheet. I'm sorry, the Google sheet that you have to do this. So now let's do the next one up, which is the current through just the red. So the current through just the red, that means I need to disconnect here so I can have a spot. So the current in the top branch, I measure that, and I've got, let's see here, 0.12, let's see, let that settle in. Yeah, we'll round it, 0.12 amps. So 0.12 amps. Let's see what we've got here for the green. Let's see what we got for the green. So we'll reconnect here and here. So the current going through the green, let it measure in, 0.47 amps. So let's see what we've got. We've got 0.12 amps. We've got 0.47 amps. We add those together, and that gets us 0.59 amps. So looking at these, again, make sure you put your answers in the Google Sheet. Looking at these, they're not exactly the same, are they? But they're not that different. So I think that rule works pretty well. All right, so next thing we got to do, we're going to have to go back and copy some numbers down. But if we go back to our next slide, all right, we're going to figure out what the resistance is for our green, for our red, as well as the total. Okay, so we're just going to use Ohm's law. We'll need our calculator for this. All right, so let's go through this. I'm going to have you guys do the math, but you're going to take the voltage across the red resistor, which you should have down there. You can look it back up if you need to, and you're going to divide it by the current through the red, because V equals IR, so R should be voltage divided by the resistance, and that would be your value there. Okay? Then, what I want you to do for your green, take the voltage across the green, okay? And we can rewind, or I can go back for you. So here's our voltage across the red. Here's our voltage across the green. Here's our voltage across the battery, okay? You're going to take each of these voltages and divide them by the currents, because V equals IR, so I is V over R. So these voltages, and like I said, pause, write them down on paper if you need to, divided by these currents. Pause if you need to. Go back. V equals IR, so you can do your math, so you can get the resistance of the red, resistance of the green, and the total resistance. And let's see, these probably don't add up to this, but we want to see if this rule works, okay? So what you're going to do is take the 1 over thing, do that, okay? Now to help you out with that math, all right, I'm going to have you approximate, okay? Remember, we've done this lab before where we've measured these resistors. I want you to sort of, to make the math easier, round it, okay? Round it to the number that's real easy to work with for this, and the number that's real easy to work with that. So that way you can find your lowest common denominator, okay? So remember what they are, find out what they were, but use those accepted values from the last ones, and when you do your math, you should get some number somewhere around, for one of the resistances, and the other one somewhere around, okay? And that will be your value of your red and your green, and your lowest common denominator you should be able to get a total resistance, and hopefully these agree somewhat. All right, so good luck. You can pause, rewind, your answers go in the Google Sheet.